Okay, we're going to learn about one more type of asymptote. We are only going to learn about one more type. Advanced Pre-Cal and Advanced Honors learns a couple more types, but we're going to limit ours to this one type. We know horizontal and we know vertical.
Wait, what is the other type?
I'm about to teach you.
No, like the one that they learned.
I'll show you. Let me teach you this one and then I'll extend this idea.
Oh, scrubs.
Okay, if the degree of the numerator is 1 more than the degree of the denominator. So if I had degree 2 over degree 1, degree 3 over degree 2, degree 4 over degree 3, so they differ by 1, the function will have a slant asymptote. Meaning a linear equation, slant. Might be like that too, slanted line. To find it, you use division. You can use synthetic if the problem will work out, or long, and I'll show you what I mean. If you can use synthetic, if the problem's amenable to that, then you can use synthetic. But there will be problems where you can't, and I'll show you the difference there. I will tell you that we are going to ignore remainders, and this is why. Asymptotes deal with very-end behavior. Negative infinity, infinity. If I have something like, as a remainder, 2 over x minus 5, and x is some ginormous number. What is 2 divided by some ginormous number minus 5?
A whole bunch.
Are you sure? 2 is on the top, divided by some gigantic number. It's going to be a really, 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 really tiny decimal, like 0.0001, something like that. Is that going to affect my problem?
No.
No. So we're ignoring remainders. Okay? Advanced Pre-Cal learns what happens if the numerator is 2 more than the denominator. So if it's 1 more than the denominator, we get a linear slant asymptote. What do you think we get if it's 2 more? A parabola, a quadratic.
Wait, they learned about that?
Yeah. If it's 3 more, there'd be a cubic. We are only doing linear slant asymptotes. I expect you vertical asymptotes to find them, horizontal, and slant. Those only 3 kinds. So, let's do an example. Here is what I'm going to expect you to do on the quiz. So here's the problem. You need to be able to find the y-intercept for me. Hold on, let's start with x-intercept. I want you to find the x-intercept. I want you to find the y-intercept. You need to find vertical asymptotes, horizontal asymptotes, slant asymptotes, holes. It's not impossible, it's just a lot. Domain and range. The quiz has 4 problems. So you have about 10 minutes a problem to figure it all out. I think 10 minutes is quite a long time if you know the order to do the things in. What's the very first step that I always do first? Factor. You always factor first. Before you do anything else, you're going to factor. First step. So don't waste time thinking what to do first. No, you factor it. Write it down. Does anything divide out? Okay, so right away I'm going to write none. Because nothing divides out. I write none. I usually do vertical asymptotes next. Vertical asymptote is where the denominator would be 0. There's only one vertical asymptote to this problem, and what is that? X equals 3. For the horizontal asymptote and the slant asymptote, I have to look at degrees. What's the degree of my numerator?
One's higher.
2, right? You're right, it is higher. What's the degree of the denominator?
1.
1. So first let's talk horizontal. If the numerator's degree is higher than the denominator's degree, what do we know about horizontal asymptotes?
There is none.
There is none.
Yes.
How do I, but is it one more than the denominator?
Yeah.
So there's a slant. How do I find a slant asymptote? We're going to divide. Can I do synthetic division here? Yes, you can, so we might as well. Because it's x minus 3. So we're going to synthetically divide in 3. You have to do it into the original problem.
So you only do that if it's like x squared on top?
No, you do it if the degree of the numerator is 1 more than the degree of the denominator. So in this case, it's 2 and 1. But it might be 5 and 4. That would also work. We ignore the remainder. When dealing with asymptotes, that remainder is insignificant. How do I write this back into a factor? X minus 1. So my slant asymptote is an equation, y equals x minus 1. Now, last period, some students were asking me, some students like to graph and then pull off the x and y intercepts, but some students wanted to know how to do it algebraically, so I'm going to do both. To find the x-intercept, you're going to set y equal to 0. So when will this equation be equal to 0? What makes a fraction equal to 0? When will this division problem be equal to 0? When the numerator is 0, right? That's the only time you're going to get 0 when you divide is when you 0 divided by something. So there are actually 2 x-intercepts. One of them is at 5, 0. The other one is at -1, 0. You will see that when we graph it, but that's how you do it algebraically. So that's what you do there. To find the y-intercept, you set x equals to 0. So in our problem, everywhere there's an x, here, here, and here, you put in a 0. So I would get -5 times 1 over -3. Is everybody clear what I just did? Everywhere there was an x, I put in a 0. 0 minus 5 is -5. 0 plus 1 is 1. And 0 minus 3. So you would not actually write this. You would write it was 0, 5/3. That's what you would write for me as the y-intercept.
So wait, it's not like -1 and 5?
That's for the y, the x-intercepts,
What are you going now?
the y-intercepts.
Gotcha.
Let's leave domain and range until we get it graphed. So let's get it graphed on here. I'm going to change to a red pen. I'm going to put my vertical asymptote of 3 on here. Now, Algebra 1 skill. How do I graph the asymptote y equals x minus 1? So you may remember how to graph a linear equation. Y-intercept's negative 1. The slope is 1, up 1 over 1. And then you keep going up that way. Are we okay? Now, how do I get the rest of the graph? Need to make a t-table. I need to choose points that are to the left of my vertical asymptotes and to the right of my vertical asymptotes. Don't worry so much about the slant one right now. When you're choosing points, look at your vertical. That divides the graph in half, left and to the right. So if the graph is at 3, what are some good choices that are to the left of 3?
2.
Okay, 2. What else?
1.
1, or we could use 0. What would be the benefit of using 0?
Gives you a better.
I already figured it out, right? But you can do 1 too. Don't get me wrong. You can do 1. I'll write 1 down here. Don't let me not. What about to the right of 3? What should I try?
4.
And maybe 5? You can choose as many points as you need to figure out the behavior. Now it's simply plug and chug. 2 minus 5 is negative 3. Oh, thank you. 2 plus 1 is 3. Over 2 minus 3 is negative 1. I believe I get 9. Someone check my math there. I am awesome. 0 I already figured out is 5/3. Do I need to rework that, or are you okay with trusting that my...
I'm going to trust you.
Okay. 1 would be negative 4 times 2 over negative 2, which is 4. This is Algebra 1. Do we see what I'm doing? Okay, 4 is negative 1 times 5 over 1, which is negative 5. And then 5 is cool because it's 0, 6, and 2, which is 0. We know, because of the nature of asymptotes, that the grid has to fit in touching the slant and the vertical. So it either goes in there. Let me use this and show you. Everybody look up here. The graph's either going to go in here, in here, in here, or over there. Those are the 4 choices. It's going to go in 2 of them. So we just got to figure out with this T-chart which points they go in. So 2, 9. 2, 9 is way up here. Agreed? 0, 5/3 is right here. So it must look something like this, approaching the asymptotes. 4, negative 5 is down here. 5, 0 is right here. Approaching the asymptotes. Now we go back and answer domain and range. There's one value that's not allowed in the domain. Where's the one x value where the graph doesn't exist? 3. What about the range?
Anything.
Anything. All real numbers. If you look at it, it goes straight up forever and it goes straight down forever. So there's no empty spots. You with me? That's what you have to do on the quiz. Let's try the next one, okay? You willing to try another one?
Yes.
Okay, let's start. I'm going to make our list here. On the quiz, I'll give you the list of everything you have to find. What's our very first step? Factor. What do you do after you factor? You simplify, find whole. So I'm going to write it simplify, but what do you notice? X equals 0 is a whole. Because that's what divided out. An X over X. I would have marked this out right here. That creates a hole in my graph. So write it down before you forget. How do I then find out what the value of that hole is? I need to plug that value in everywhere there's an X. Good. It would end up being 0 squared plus 0 plus 4 over 0 minus 2. So you would actually write it 0, negative 2 is going to be a whole.
So the whole is always the x.
The whole, yes, the number is the x coordinate, then you have to find the y coordinate.
Okay.
Because we wouldn't write this, we would write it in simplified form. Okay, let's find our asymptotes. What do we know about vertical asymptotes? Okay, there's only one, x equals 2. You're tempted to write another one as x equals 0. It's not an asymptote, it's a hole. Okay, horizontal. We have to look at the degrees. What's the degree of the numerator? What's the degree of the denominator? 2. So there are no horizontal asymptotes, but there is a slant asymptote. Can I use synthetic division here? No. So I'm going to find my slant asymptote. I'm going to have to do a little bit of long division here. You can use a simplified. I think you're going to get the same thing. Let's look. Somebody do it with the simplified version real quick and tell me if it's the same. If I take x squared into x cubed, I get x, yes? Change the signs because I'm subtracting. You should. And then x squared. Change the signs. 10x is our remainder. This is our remainder, which we are going to ignore because it has little meaning to me when we're talking about asymptotes. So our slant asymptote is y equals x plus 3. Is that what you got when you did it?
No.
Let me see. 2 into 1, 1, 4. Oh, 1. Should be right here. X plus 3. So it does work. I've just always done it with the original. I don't know why that is. Okay, let's put all of everything on here. Do you like finding the x-intercepts and y-intercepts from the graph or using algebra? Okay, you like algebra. Let's do those real quick then. To find the x-intercept, you set y equal to 0. What's the only thing that's going to make this numerator 0? Right here. What's going to make this 0? 0, 0 is the only thing. Because that x squared plus x plus 4 is never going to be 0. To find the y-intercept, you set x equal to 0. So if I put a 0 in for x, I already did that, didn't I? That's where my hole is. So you need to mark that. Now let's put all my asymptotes on here. 2. How do I graph x plus 3? I know it crosses at 3 and goes up 1 over 1. So I know my graph must exist in 2 of those spaces, 2 of those 4 spaces. The only way to figure it out is to make a quick t-chart. If my asymptote is 2, what are 2 numbers to the left? Let's do -1, 0, and 1. I've already done 0. That's where my hole is. So I'm going to go ahead and draw that on there. But that may help us. I know that it's 0. It would be -2, but that's my hole. But the graph's still going to go exactly to that point. You're just going to leave a hole there. And then what number should I choose to the right of my asymptote? Three and 4? Yeah. Thanks. Sorry. So you just need to plug and chug in here and get some t-table values. -1 would be -1 squared is 1, -1 plus 4 over -3 which is negative 4/3. And then the next one's 1 squared plus 1 plus 4 all over negative 1, which is negative 6. Stop me if you think I'm not doing my t-value correctly. 3 is going to get kind of big here. 3 squared is 9 plus 3 plus 4 all over 1. So I believe that's 16. And then 4 is also going to be pretty big. 4 squared is 16 plus 4 all over 2, which I believe is 12. 24 over 2 is 12. And now you put these values on the grid. So let's see, negative 1, negative 4/3 is here, and 1, negative 6 is down here. So this one's going to look something like this. Something like that. And then my other values, 316 is way on up here, way at the top. And then 412. So we know it's above in this little corner, so we're going to draw it something like in here. Because I'm basically interested if you can figure out in which sections of that grid there are. Now, here's something that I need to point out to you. Domain and range. There's one value not allowed in the domain. 2. Somebody talk about the range here. You're gonna need a calculator or some calculus. Well, there's a big gap though between the two graphs. See how there's a big gap between this graph and then this graph? So we don't know what those points are without some calculus or calculator. And since this is a no calculator quiz, I'm not going to ask you about it on this one. Cool? Yeah.
When doing domain and range, wouldn't you also include the whole for the domain and range?
You would actually. Thank you. I often forget to do that, just like some of you will forget to do that on the quiz. So let's stop forgetting that. How about? So the range, we know it can't be -2, but the rest we don't know, so we're just going to say we need a calculator and not worry about it. What's that?
Oh, no, I can't ask 0.
Because there's a hole there? Because if you put in 0 into the original equation, it would make the denominator 0, which we can't have.
So really we could find domain and range first.
Yeah, you could have. Not range, but domain, yes. Okay, we still have 10 minutes, so here's what I want you to do. I'm going to start writing all the information up here. You write it on your paper, and only look up here if you get stuck. See if you can do it without my help, okay? See what you guys can find without looking up here. See if you can do it. Sure. Because you can only use synthetic division if you're dividing by x plus 2, x minus 1. You're dividing by either 2x cubed minus 8x or 2x squared minus 8. It does, actually. Questions so far? You getting what I'm doing? The long division was a bit of a challenge because it involved a fraction. I won't put one that with a fraction on the quiz, but it's not above what y'all should be able to do.
Teachers, please excuse the interruption. Football practice will be held after school today at Memorial Field. That's football practice after school at Memorial Field. Thank you.
What? I bet it's not that flooded.
You just like act real tough. You'll act really tough. Touch people.
Guys, make sure you're trying to get this figured out. Oh, wait a minute. I don't know if this was here. Let me look here again. Oh, that's my problem. This is a 2.
Makes sense, right?
This ends up being 8/3. Okay, and it does look something like this.
What's the domain and range?
Domain is cannot be -2, 2, or 0, and range is everything but 0.
Oh.
Because of that whole. Your homework is 2, 6.
Yo,